In this small video, I want to showcase my two submissions to MATLAB File Exchange on real-time optical flow. First, the tutorial on real-time optical flow, which page is now in view, and secondly, the optical flow with MATLAB's computer vision toolbox. So first off, it's the tutorial on real-time optical flow. Both of these small submissions are very easy to use, and I'll go right to MATLAB to illustrate that. First off, we'll do the tutorial on optical flow, and there's a runme file. What you can do is you can right away run that one. I have it set up now for video, so that I can see myself talking to you. I should say my name is Stefan Karlsson. I'm the author of these two submissions. And as you can see with the first one, it's very easy to get access to the video of your system. You do that by changing the movie type in runme. You can, well, in this case, there are three possible syntaxes for accessing the camera. Getting the default Windows camera, you can do it by this option. If you have several cameras, you can add another integer. I have to do that. I have two cameras and one of them is broken. And thirdly, you can specify the resolution of the camera device. Only square images are supported for now. You have other types of movie input. You can also use a video. Any kind of video that is supported by MATLAB will work. More interesting now is to check out the synthetic video sequence. The original sequence is here on the right, and we can modify that one in real time using the keyboard keys like left and right. You can also put some rotation on it if you like, and cancel that out like that. And what else is there? That's right, you can let it move in a predefined pattern, shaped like an 8, and you can introduce some lag time if you like. That's kind of useful when you want to zoom in and look at what's happening, especially for flow calculations. All the MATLAB toolbar options are still working here, so you can zoom in like this, pan around as it's updating, and yeah, and then you have the nice keyboard interface here. Okay, let's see. What we just saw was edge detection, and that's the method edge. Instead of having that one, we might want to have something like the gradient option. The gradient option, we see the three components of the gradient calculated over the sequence. As before, we can modify the sequence in real time using the keyboard. See exactly how those components change around. So it's quite useful to get an intuition about what's happening later on when we're calculating optical flow. And for the method, we have a couple of options that will generate some kind of flow output. We have the traditional Lucas and Ganada, and we have the one called flow1. Why don't I go right ahead and activate that one on the camera. There we go. And that's me again. Well, one of the things you can use this kind of flow for is to analyze the micro motions of your face. Lots of interesting applications. It's fast, it's not terribly accurate, but it's useful for picking up on some interesting dynamics, I think. So, what else can I show you with this one? Oh, that's right, the final option here determines at what scale the calculations are done. You can go for fine scale as well. And while we have fine scale, why don't we check out the last version of optical flow and see what happens when we go for a bit higher resolution now. So because we cannot really put MATLAB quivers for every pixel, it would totally clutter the screen. I'm using a nice color coding. This is kind of standard in the optical flow literature as well. This one is a little bit special, a bit novel, because I'm mixing it up together with the real video feed. Again, you can see So that does it for that tutorial. I should say this is part 1 in a planned series of 3 tutorials. I'm almost done with part 2, although it does require a bit more work than I thought it would be, so I can't really promise when that will come out. You can also play around with the built-in optical flow routines in MATLAB if you're lucky enough to have access to the computer vision toolbox. So that's another submission. It's very similar to the first one. It looks like this, and you can download that one as well, of course. I have that one over here. Like the other submission, we have a little RunMe file, which I now open. And it has very similar interface. Essentially, it's the same, except that for methods now we have only 2 options, and it's Horn and Schunck and Lucas and Canare. I'll just run this one with the camera right away so we can compare the output from the other toolbox. And here we go. So this is with the built-in optical flow of MATLAB. This one is a little bit more sensitive to the contrast. I would say well, first off, this is a global method. I won't go into any details on what that means in this short video, but we would actually expect the results to be a little bit better than the method I showed you previously. So there are some issues with this method. If the contrast is high, as with my hair up here now, then you can see that the motion vectors become quite nice and stable. But as soon as the contrast goes down, you don't have very much to go on. Here's my mobile phone. It seems to be working reasonably well. Yeah. We can also check the output on the Lucas and Canare version. And we will see this really strange output. Actually, this is correct. However, these 2 methods output flow at quite different scales, about a factor of 10 difference. So for that reason, I have the scale parameter here, which you can change. I think 0.5 was a good value for the camera feed. There we go. That makes it look a little bit more reasonable. So this is a Lucas and Canare implementation. It has the same issue of needing a high contrast. These methods are implemented by some really smart people, and people who are also very knowledgeable about making efficient algorithms, it seems, because they run very fast. It's a compiled MEX module, and as such it means probably someone has been sitting with C code and really been squeezing as much efficiency out of your hardware as possible. And for sure, my pure MATLAB implementation cannot compete with the efficiency of the built-in toolbox. I really like many things about this computer vision toolbox, so let me be the first to recommend it. However, I would say if there's one thing I can criticize, it is the fact that there is no good visualization of the kind that I've made. So this small submission, I hope will fill that blank. So it's very easy with a few simple settings to start up, looking at some video feed and really comparing the output with this kind of color coding. And with that, I'd like to thank you for your attention and hope that you will have fun with these submissions. Please do contact me if you find any issues with them, or if you have any comments or feedback in general. So have fun coding.